Good morning, everybody in the lecture hall. Good morning, everybody on Zoom. Good morning, everybody watching us from the future. Today I'm going to finish this. I just have a few more slides, and then we'll proceed to MapReduce. So just to make sure you have this high-level view on validation and data frames, and then moving on to Parquet and binary formats. So the idea that we have is that we have these very generic JSON documents in here. And if they are valid against a well-behaved schema, then we can actually display them like this, right? So this would be this. And then, of course, there is a contrast to understand that has to do with the constraints, relational, atomic, and domain integrity. So in that case, if it's a table, we say it's a flat data set because there is no nestedness. And if we have nested arrays, nested objects, then we say that it is a nested data set. And that breaks the atomic integrity, right? The atomic integrity is broken, and you can see the lines here don't go the whole way. And this is how you recognize, in that case, you have nested arrays of objects. Okay, so that would be these data frames. Who agrees with that? Okay, awesome. So these documents correspond to this, and these documents correspond to this visual right there. Okay. Another way to distinguish is between homogeneous and heterogeneous data sets. So a homogeneous data set means that every column has a specific type, right? So Booleans, strings, numbers. Heterogeneous, and also the same support everywhere. Heterogeneous, one of the ways to be heterogeneous is when you break relational integrity. So it means you might have missing values, or you might even have extra fields in there. So it means that not all the JSON objects have the same keys. Some have extra keys, some have missing keys. And that breaks relational integrity, and we say that it's heterogeneous, right? Another way to break, to be heterogeneous is to break domain integrity by having multiple different types within the same column, right? So who agrees that this corresponds to this, and this corresponds to this? Right? Awesome. So technically speaking, that's not really a data frame, even though you could make it a data frame by adding all of the columns, and then you allow nulls, right? You allow empty values in there. So now, if you have just a bit of nestedness, let's say one level of nestedness, let's say you have arrays of objects in some fields. You have a bit of relational integrity broken, like you have a few nulls here and there. That's fine. You can use data frames. You might even be able to use SQL if you push a bit the boundaries. But if you have too much nestedness, or if you have a full heterogeneity that you start needing variant columns, like here, where you have some nested tables, but also atomic values, that's a huge mess, right? You can see in the JSON, we have here a string value, and here you have an object, and so on, right? So this is very heterogeneous. If later you join a team and they ask you to use variance columns and to hit it with a hammer, to fit it in data frames and query this with SQL, you run away, because this is not adequate anymore. So SQL and tables were never designed to handle a lot of nestedness, a lot of heterogeneity. That's not what it was designed for. So in these cases, we have better suited systems like document stores, like JSON native databases. So it's Halloween, so it's actually very, exactly the right moment to show you these things. But I really want to give you the intuition that when it starts looking like this, you're no longer using the right system for your data. Okay? So in that case, it's both nested and heterogeneous. It breaks everything. It breaks atomic integrity, it breaks relational integrity, and it breaks domain integrity, the one on the right. Who agrees with that? Right? Okay. So that's the intuition that I want to give to you. Okay. So now you see the power of JSON and XML. They have the flexibility to give you heterogeneity and nestedness in a very native way, while you can still validate them if you want, and then you're back to the good old world of tables or data frames if you allow breaking some like one level of nestedness. Okay. Now, it turns out there's plenty more formats, and even better ones than XML or JSON when the data is valid. So you might have heard of some of them. So data frames, that's the visual. It's very common. It's in Pandas. It's in Spark. We'll see in a couple of weeks. JSON, CSV, XML, YAML, you know them. Who heard of Parquet? I think I already talked of Parquet, right? Avro, maybe? Some of you? Okay, protocol buffers? Yes? So these are all kinds of technologies that have to do with the idea of having schemas that validate some data and then storing that data in a way a bit optimized given the schema. And so the idea of a format like Parquet is that you short-circuit the whole thing. You know, you parse, you read, you parse, you validate, and so on. With Parquet, what happens is that once you have open your collection of JSON documents, let's say you have a huge JSON lines file that has a lot of JSON objects. They all look the same. So you build a schema, you validate them. It fits in a data frame. So you have your annotated tree right here that actually fits as a data frame. And then it's magic because once you have a data frame like that, you can write it back as Parquet. And Parquet is able to store these things with a schema. It's much smaller than the JSON lines data set. So it saves you a lot of space on disk and it's super fast to open. So the first thing you should do when you download a data set from the internet and it's well structured, you validate it, you save it back as Parquet, and then you use Parquet, right? Because it's much faster to open and much more efficient. Okay, so it's basically just reading and writing from Parquet. It's a binary format. You cannot open it as a human being. And here it's direct. You directly get the valid data and you write it back. So this is why Parquet, I think many systems can save the data as Parquet when it is valid, when it has the form of a data frame. If it's heterogeneous or that doesn't work anymore. Some newer systems allow you to store variants in Parquet, but it's not compatible with all the systems. And again, as I said, this should be an alarm signal. When you start seeing variants and that kind of things, then it starts indicating that it shouldn't be with data frames. Okay. So now, for all these formats, the good news is I gave you a very general knowledge about these things that should make it very easy for you to learn them. So I'm not even teaching them to you, but it's going to be a walk in the park. You just need to be able to have some classification in your mind, right? So some formats only support flat values, so CSV, for example, and some others support nestedness, JSON, XML, Parquet, and so on. Some formats are textual, like JSON, XML, CSV can be opened in a text editor. Some others are binary formats, like Parquet, so they are much more compressed and faster to open. Some of them require a schema, some others do not, right? So Parquet requires a schema. You cannot create a Parquet file if you don't have a schema, right? And in fact, it's because there is a schema that Parquet is so efficient. Because if you don't have a schema, so JSON, XML, and so on, they don't have a schema, you realize that you need to repeat the keys when you don't have the schema. In every JSON object, you need to repeat the keys. But in Parquet, you don't need to do that. You don't need to repeat the keys because you know the first value is that key, the second value is that key. It's all in the schema. So that's one of the reasons why a Parquet file takes less space. In fact, it's the same for CSV. In a CSV file, you just put the keys on the first line, the headers, and you don't repeat them on the other lines, right? Because it's always the same keys on every line. Okay, so basically for every format, just ask yourself for each one of these three yes-no questions. You can ask yourself where it belongs, and then you just look at the documentation. And what I want to show you, that's just an example. This is an excerpt from the Parquet documentation. It's a list of some available atomic types in there. And normally you should feel right at home. There's nothing really new in there. Just the names might be different, but again, it's like Schweizerdeutsch, right? You just use different names for the same thing. Boolean, int32, int64, that's a long. They even have longer integers with 96, double, decimal, strings as UTF-8, enumerations, just a fixed set of values to pick from, binary formats, fixed length byte array, you can even guess from the name, dates, and so on. So do you realize you already know all of that, right? We've seen the list of types. Who is comfortable with that, right? So that would be the same for every format you look at. There's just a documented list, and you just need to look at it. That was the atomic types, and now the structured types. Again, the names will change, but it's going to be the same almost every time. You're going to have arrays, and you are going to have objects, right? So in Parquet, they call arrays lists, and they call objects maps, right? It can change, right? Some do not call them maps, they call them structs. So it varies. And you might have here and there a few additional structured types. So some support sets, for example, you can have sets. So that's something you don't have in JSON, but you might have formats that have sets. And then you have formats that have maps, but in a different way than objects. They have maps, for example, from dates to strings or from dates to binary and so on, with a type for the domain and a type for the codomain, right? So that's a different kind of maps than the objects. But anyway, for this, you just look at the documentation and you will figure it out. The top two that are the most important ones are arrays and objects, no matter what they are called in every technology. For whom is that clear? Right? Okay. Protocol buffers is again that same idea that it's a binary format that needs a schema. And so a schema in protocol buffers looks like this. That's Google technology. And you see you have the types. And again, it's always the same types. These are just structured types. These are objects, actually. And you can also define schemas for them separately. So here it's even recursive. Required, repeated, optional. It just tells you if it repeats, just like XML elements can repeat with min occurs, max occurs. That's the 0 or 1, so that's the question mark, that's the exactly one, and that's the star symbol, basically repeat it. And here are the names of the keys. Who would feel comfortable parsing a schema like that as a human being? Right? That's very intuitive, right? And again, for the details that you need semicolons, blah, 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 you just look up the documentation. That's just a matter of documentation. So in summary, you should be able to very quickly learn a walk in the park, any format, any technology, because it's more or less the same thing, just with different names and maybe a different list of types. So in summary, we saw that for semi-structured data that can break rules, like relational integrity, atomic integrity, and domain integrity, we decouple the validation from the well-formedness. So it means that you can have JSON or XML that's well-formed but not validated yet. Then you're on the left. There's no schema. It's fully heterogeneous, native JSON, native XML. If you validate it and the schema is well-behaved, then you are able to put them in data frames. And then a lot of possibilities start opening to you because you can store it more efficiently, for example, with Parquet. If it's even flat, you can store it in a relational database. You can use machine learning and so on. So basically, it's very common to have real-world data that looks like this, and then you clean it up for machine learning, and then you structure, your feature and your label columns to make it work with a schema, right? So this is the high level view. Okay. So now, some of you already answered. Awesome. So I want to check where you are with this lecture. Hopefully it was a bit easier than HBase. So HBase was of course very, very complex. And here it's really more like looking at documents and seeing the structure they have and constraining the structure. And very happy to see that some people even understood everything. By the way, those of you who understood everything, do not hesitate to explain to others. It's really a good exercise even for you, because the best way to learn further is to teach. So when you have to explain to others, then you realize if there's any corners that you still don't fully master. So it's a great idea to interact and help other people. All right? Okay. If you have any questions, I'm here. The TAs are here. There's the Moodle forum, but you can also send us an email and we'll gladly help. And of course, there's the textbook. I put the JSONic tutorial. Who actually tried the JSONic tutorial of this week? a few of you, not this week, you will see that in this week's tutorial, there's it shows you how to use JSON schemas in JSONic and how to validate some data with it. It shows you how everything basically belongs together in the same system. Okay, so I very much encourage you to do that. Okay, so I'm going to stop here.